Okay, now on to the next RC. We have this thing here, which looks pretty cool. It has an internal battery, but there's no sign of life from it. The controller's showing light, but it just flashes as if it's trying to connect to something. There is a charge port on this, but there's no cable with it in the box. There's no there's a small instruction manual with it, but it doesn't tell me exactly what voltage is meant to go into this. So I'm going to need to open it up to make sure. I would guess that it's like a 3.7. You get wee USB cables for this here with a built-in voltage converter, but I don't know if this one has the charging circuit built into it or if it's external on the USB. So, and I couldn't find anything online to tell me for sure which it is. So I'll need to open this quickly just to see if the charging circuit is inside or if it's part of the charging cable you're meant to get with this. Let me find somewhere to pry this open from. There we go. Okay, so it's this other side that comes off. Now, charging circuit is, well, there's the battery anyway. 3.7 volt battery cell. Charge port is here. Comes down. Comes into here. I'm guessing that means it needs to be off to charge. Is that what that means? Let me just check some things here. So the positive of the charge cable comes here, yeah. When it's off, it's connected to the middle pin, which goes directly to the battery. So this needs an external. This needs an external USB cable with a built-in charging circuit to deliver 3.7 volts into this, or 4.2. That's something I'll check. I have another RC here, the wee drone that came with the USB cable with a charging circuit in it. I'm just going to check because it externally charges a 3.7 volt battery. I want to see what voltage it puts out. Is it 3.7 or is it 4.2? Okay, so that's the cable I'm talking about. It's a USB port with a charging circuit in there, and you connect this directly to the battery for the drone. But I wonder, does it fit this one too, actually? Let me just test this. Yeah, it works for that one too. Weird. That's strange. These must be kind of universal. Let me just check here. It's not taking any power. The cable works, it's on, but this battery's not taking any voltage. I wonder, is the cell dead? Let me check this. What voltage is the battery reading? Probably nothing. Let me bring that into view, sorry. You can see that. 2.6. It's reading 2.64. I'm going to try and inject power into this with my power supply to see if I can jump start it. I'll inject 3.7 volts into it to see what it does. I'll set a limit of about 500 milliamps. I'm just going to use these same cables to inject the power. Okay, so we're at 3.7 volts. The battery is taking 500 milliamps, so the battery can take power. It was probably just too low and the charging circuit wasn't being activated properly. Alright, now that's got to reboost. I'll see, excuse me, if it's got to reboost, I'll see does this, yeah, it's taking power now through the charging cable. The voltage was just left that long, it was too low, so it just needed a reboost for the charging circuit to activate. So what that means, for this thing to charge, it needs a USB circuit. For this thing to charge, it needs an input of 3.7 or 4.2. Let me just check that now that it is actually, now that this thing is taking charge, I'll just check how much this cable is giving out to see what should be going into these things. Let me try. My voltmeter again. Okay, so this charging cable is giving out 4.4 volts. So about 4.2 we're looking for. There's no load on that, so we'll assume when there's a load on it, it'll go down to 4.2. So for this thing now, we need a circuit giving 4.2 volts going into this to charge it externally. I wonder, can you buy those? Let me just check them. Hold on, let me check. Okay, so I can't find anything online that is this type of setup, but with the barrel jack connector that I need for this DC input. I was even looking for an adapter to fit this and the other end have a DC barrel jack, but I couldn't find anything, so I might have to make something for this. Some sort of, I don't know if I'll make a whole charging circuit or if I'll just make a way to, I could buy another one of these, cut it off, cut this end off and put a barrel jack on the end of that right enough. I could do that. That might be the best way to do it actually. Because I could make my own wee charging circuit here, but I'd rather just have one that's designed to spec to make it more reliable. So what I might do is order another one of these charging adapters and just fit a new end on it to fit into this barrel jack. So I might continue the video from there once I have the new adapter, and I'll make the new connector, the new end on it. So I'll probably cut to that now. Okay, so this is the wee USB charger that I ordered off Amazon, but I actually put this in a post to my page that this is defective. Well, I got two in the packet, both of them are actually defective. It says on the charger here, input 5 volt and then 0.5 to 2 amps, output 3.6 volt to 3.7 volt, but that is just a blatant lie. If I crack this open, I can show you now. So this is what it looks like when it's open. There's absolutely no circuitry in there to break down 5 volts into 3.6 or 3.7 volts. This is just a wee circuit to light a wee red LED when you connect a load to this device here. So that's a scam. I put a post on that just because that's a potential fire hazard. If you were using that there and it's putting 5 volt into a battery that's only expecting at most 4.2, that could overheat and that could cause problems. So I can't use any of these things, so I guess I am going to have to make my own wee charger, which I thought this would be a safer option, but of course that's wrong now, so I'm going to have to make my own because Any that you buy third party are probably going to be useless. So what I need to do is I need to create a cable that takes in 5 volts and outputs 4.2 volts. That's just output 3.7, but the battery is a 3.7 volt battery, but its maximum voltage would be 4.2. So I need to get a device that takes in 5 volts and outputs 4.2. So I have a couple of wee circuits here. Let me see. I should have a wee dedicated battery charging circuit here. Hold on. So for that, I'll probably use this wee circuit here. What it does is it takes in 5 volts and it puts out 4.2 to a lithium battery. There's wee LEDs on this too to tell you when the battery's charging and when it's full. And this is what that other USB charger was missing. If I zoom in here, this wee integrated circuit here, this wee chip, that's what breaks down the voltage from 4.2 or from 5 volts to 4.2. That's what that other circuit was missing. That other circuit just had resistors and an LED, just a complete scam. So this is the important part here. Everything else here is just these have resistors for LEDs and everything, and resistors to dictate the current. But the main part of the circuit is this wee chip here. So what I might do with this actually is I might get rid of the port here and just hardwire on a USB port. So you just plug it in and the cable goes straight to this, and then the cable goes out into this. So there's no plugging a cable into this, because I can see that breaking in the future, that wee USB port there. And I'm not sure what way I could design this. That USB port looks nice and tidy, so I might just get rid of it altogether. So I'll probably cut off that part of the board here actually. Or I might just remove that port and keep that part of the board for stability. So yeah, first thing I'm going to do is remove that USB port there. So I'm just going to use my hot air gun and just remove that port. Okay, so with the port gone, I'll need a USB cable on this side coming in. So taking 5 volts in, it gets broken down, and 4.2 volts out. So I'll need a USB cable now. So what I can actually do is get some use out of this piece of crap here. I'll use it as a USB port, and I'll use the cable to connect into this. So that's what I'm going to do. Actually, I'm going to cut this end off here and wire it straight into this wee circuit here. I'm going to cut this end off. The wires are so thin on this cable, they break so easily. So I need to be careful not to pull on it too much, or it'll just snap right there. So that's our USB cable wired into it. I'm just going to plug it in here and test it, make sure it's giving out 3.7 volts. So you can see that blue light's on, telling us that there's no current being drawn. And you can see, yeah, 4.2 volts, sorry, not 3.7. 3.7 is the battery when it's flat, 4.2 is it when it's full. So obviously this will charge the battery till it's full. There's no red LED on this, this cable right now, so I'm taking that as a good sign that it will only turn on when there's current being drawn, so we will be able to use that as a charge indicator. So it wasn't a complete waste of money. Okay, so next thing we need to do is wire a cable onto the other side of this that will fit in here. Now I need to try and find the right adapter for that and wire something in here. And I might also well, I will shrink wrap this or cover it in some way so it doesn't look that bad. And when I get this wired up, once I wire this up, I'll need to see as well what the current draw is on this, because I believe it's a 500 milliamp battery in here. So we don't want to charge it too much, otherwise it'll overheat the battery. So I'm going to try and get something to make this cable now and check everything, what the draw is and all that, and check our power LED. Alright, this is what I've come up with for now at least. It's a standard DC barrel jack with an adapter on it to fit into this, because the standard DC barrel jack is too wide. So it'll do for now for testing at least. So I'll solder this on and check current draw and all that. Okay, so we'll plug it in now and test it. Let me just test this to make sure the voltage is getting through. Yeah, we're getting our 4.2 volts. See the red light on now. And this is drawing 0.18 amps, which I think is perfect because this is a 500 milliamp battery, so that would be that'll be a perfect current draw for that. So I don't need to change anything on this to increase or decrease the current. So what I need to do now is just solder everything 100% and tidy this up. Now I've just stripped back the wires on the USB part a bit more so I can kind of fold them up and double them up so that there's more for the solder to hold on to on the circuit, because I was afraid that those wee thin strands might break. But if I fold this back and twist it around, it'll give a bit more for the solder to grip onto. Just like that. Okay, so I'll solder that back on the inside, the side taking the power in. Oops. Now to tidy this up, what I'm going to do is use a piece of shrink tubing. This is the biggest one I've got and it just fits over that perfectly. But once it shrinks around the circuit, there'll be gaps left here. So what I might do is, once I have the whole circuit and wires connected, super glue the edges closed and then let it shrink in the middle and see does that look alright. Just because I don't want gaps left and you know, being pulled open by anything. So I'll wire on our wire to the battery now. Okay, so that's the soldering done. I'm just going to clean up that flux a little bit. Now just to test that before I finalize everything, does that still charge properly? Yeah, that's still charging properly. Okay. Now, so now we'll put our shrink tubing on and super glue the edges of it. Now I don't know if it's a good idea or not. I'm going to try it and see how it goes. What I might do is just put super glue on both sides and use wee clamps to hold it down here. Hold on. Let's just use these clamps here. And then just the other side as well. So I'll leave that for a few minutes to dry out. I'm not sure how well that'll hold, but I'll heat that anyway now and see how it looks. Right. I should have actually covered that as well with something. I'll see about doing that after. I'll see how this turns out first. Okay, so that super glue is giving off quite strong fumes that are actually stinging my eyes. So if you're doing this at home, be very careful of that. Actually, you should probably wear some eye protection if you're heating up super glue like that. Right, I think that's as much. Right, I think that's as good as it's going to get there now. So the problem was there's too much of an overlap on this actually. So what I might do is slide on another bit of shrink tube over here, so that'll hold on to this and cover these red and black wires. Because that side actually, it is what it is. It's functional. It might not look the prettiest, but it'll do the job. Like, it's quite strong there. And that super glue makes that even stronger. So I'll do the same again. Super glue it closed around this black wire with another bit of shrink tube. So I'll just feed this on here. So that'll go over here. And I'll just super glue it closed around this wire again. So that's that side glued. Now we'll just do the same thing again. We'll just heat this up and hopefully that side stays stuck together. So that looks like crap, but the question is, does it work? I might need to put a bit of extra super glue there just to tighten up that wee gap with the wire, but that's easy to do. Yeah, it's cool enough now. Okay, so we'll plug in the USB side and we'll plug it into the car. And it does work. Now, as I was suspecting, you can't see the lights on this anymore to check whether it's charging or not, but the light on this will do the same job. Now, it doesn't look great, but it works and it's safe. There's no way this is going to overheat or cause a fire for the current it's drawing, whereas this one that I bought could have very possibly done that because it was just overpowering the battery. It was giving it too much voltage, but ours does work, and it means this RC car now, instead of going to a skip or a recycling centre, can be donated to a charity shop and some kid can get some use out of it now. So I'm happy with that. So all that's left to do now is to charge it and test it. Now that that's had a bit of time to charge, I'll just take it off now and test it. So it's just turned on. Some cool LEDs there. And this is the controller. Yeah, that's pretty cool. And now with our homemade cable, it's working 100%. It can be charged again now and used instead of just sitting there gathering dust with just a simple wee charging circuit here and just a couple of cables on each end. So yeah, that's that repair done, and I think I'll end the video there. All right.